Okay, great. So, um, assignment O2E. Um, we're going to start getting into another level of simulation, and this is solar analysis. And this is where we're actually getting into some plugins, uh, which in this case would be called Ladybug. So Ladybug is a environmental plugin that uses actual weather data or actual like solar and weather data um, to run simulations on our geometry. Um, there are a lot of Ladybug is like four plugins in one, because there's Ladybug, which is solar. There's Honeybee, which measures actual like the inside of inside radiance of the space, and then there's Dragonfly and Butterfly. I mean, I believe there's four of them, but it's they're all very powerful tools, and they're really changing the way how we're starting to design, because before we would have to maybe we'd have to hire a consultant to perform these analyses, and and now we're actually able to do these in-house and do them relatively quick. We're architects, we're not lighting engineers, but this still gives us a really powerful tool that we can play around with and get some different strategies of how we can address these solar concerns. The important thing is also like some of the outputs for this is just something that we're not used to. That we just don't have the educational background to really dissect into how these spaces are good or bad. So it's great though that we at least can start to digest a little bit of it, and then at least make some informal decisions and get us pointed to the right direction where we can hand this off to an engineer to finalize some of the results. But it's still a really powerful tool, and actually it's changing changing quite a bit. We have a local firm here that has all their engineering in-house, and they used to charge quite a bit of money to do these simulations, because by traditional software it would take a significant amount of time, and they charge $90 an hour to do these simulations. With Ladybug, these simulations are done much quicker, and it's a free software. And suddenly this company changed their business tactic to saying, okay, hey, we'll provide this for free now. And now that was created that now that really changed their business practices, because then their competitors had to charge, and their fees were a lot less cheaper because you can create these simulations so quickly. So it's a fantastic tool, and it's also very interesting that it's free, and that is a whole movement right now for this visual programming on having this software be free for everyone and accessible for everyone. And why do we have to spend all this money for the license? We should be sharing all this information, because by sharing, everyone can make a more sustainable building. So, which is a fantastic, I think, a stance on things. It's so I think a lot of people are like, why can't you can make money off this? But I think it's that's like, this is all about sharing our information. So the first thing is we're going to continue on with our scenario with the developer, and it simply is the developer wants to see a solar analysis. So that I've never really had a developer ask me how to do a solar analysis, but it's ethically we should be doing it on all our projects, because especially with these tools, they're so accessible for us. But essentially, we're going to use Ladybug to perform a solar analysis, and then we're going to capture that view, and then we're going to 3D print the proposed tower. I want to keep our 3D printers up and running, so we are going to be using the massing that you generated from O2D, and we're going to use that massing to perform a solar analysis and then 3D print that mass. So what you should be submitting is a 3D massing model, photograph of it, a perspective image of your solar analysis on the output of it, which should look something similar to this, and a photograph, like I mentioned, photograph of your model, and a high-res image of your Grasshopper script. So should be pretty simple. I think this is a lot less involved from the previous assignment, but these are going to be important because they can generate outputs for, like, we can start to create a parametric skin, and that skin can respond to these outputs. Or we can write a Galapagos script where it's trying to we can manipulate the building mass to get optimal solar exposure. So it's all good stuff. So I'm going to jump in. So to download plugins for Grasshopper, we want to go to Food for Rhino. That's the website that it has Rhino plugins, and it has Grasshopper plugins. It's foodforrhino.com. You will have to create an account. The account is free. And honestly, I think all they do is send you a monthly email of just saying, hey, this is what's coming up, but I'm sure you can unsubscribe from that if you don't want to see it. But it is actually, those emails are fantastic, by the way. But it's a very simple website, and it usually tells you some of the top Grasshopper plugins. For example, this is one of the top ones is Pufferfish. Pufferfish is a great great tool that uses that's able to just take the geometry to the next level. In his plugins, he calls it tweening, which is a generative algorithm that interpolates geometry, lines, or points through space. And actually, it's really good if you want to start creating some really complex forms. In fact, this 3D model, this 3D print was actually generated through Pufferfish. So it's a great plugin. It's starting to be the standard plugin, I would say. Like, there's usually these go-to plugins that are essential at least I would say are essential, that we use almost every day. So Ladybug is one of them. Pufferfish is starting to be one of them for sure. Now this website doesn't have all the plugins. There are some that are different. Like if we use, there's a really important Grasshopper plugin called Weaverbird. And this deals with meshes. And this is a very different plugin, or a very different installation as well. And it's not even in Food for Rhino. But it's a great plugin that deals with, it smooths out meshes so you can make some very Zaha Hadid or organic forms quickly and simply. But for Ladybug, we're just going to show you, we're just type in Ladybug into our search bar. And here it is, very first one that comes up, Ladybug Tools. And so we'll see it has these 4 components. We are not going to use any of, we're only going to be using ladybug. We won't be using honeybee, dragonfly, or butterfly. But, and I also specified it in the assignment sheet, we'll create your login account, and we want to get Grasshopper Win 6, the latest release, so the 0.0.68 release. And once you log in, you'll be able to just click download on it. 6.8. So yeah, ladybug, honeybee. We'll download it. And it shouldn't take too long. But these are some pretty great tools that you can start to create some sun maps. You can start to see how the sun is affecting the just how the sun is working with the site, how the building. You can start to do wind roses. A lot of different unique climate studies that we can do. So once that's downloaded, we have to unzip it. And when we unzip it, there's going to be a Word file. And that Word file is going to tell us to go to this link. And that link is going to tell us our installation instructions. And this is very quite easy. For this one, you can ignore that. We don't have Rhino 5. We have Rhino 6. But it's really just and step 0, we don't have any versions of Ladybug, so we can skip that one. Make sure you have a working copy of both Rhino and Grasshopper. Yes, we do. Open Rhino, type so you launch your Grasshopper. You open up your folder, and you just drag and drop all these user object files into your Grasshopper script. So what do you mean by that? It means when you unzip your file, you'll see a folder called Ladybug, and you highlight all those and drag and drop them right into the canvas. And that's it. It's installed. It's as easy as that. And then you can start creating these, start working on the script to create these studies. There are a few things that I recommend you do drag and drop some additional things in the folder. Let's go to my downloads. Let's unzip this. So if we go into GHA, these are all great tools that I would also just drag and drop in. I don't think it won't affect the script at all, but they're good ones to have. But essentially, but that's all it is you click on these folders, you do a Control-A, make sure your Grasshopper is up and running, drag and drop it right in there. Now it says that because I already have it installed, but, and that's it, that's all it is. So then we're gonna start, and then we can start working on the script. There's also one other plugin I want to talk about. It's actually, it might be coming in default now, but it's Kangaroo. And Kangaroo is they're all, of course, they're all named after animals, but Kangaroo is also a fantastic plugin. It's a physics engine. So if you have a mesh and you want this mesh to behave like fabric, we can do that. If we want it to behave, blow in the wind, if we have this ball, if we have this sphere and we want it to have elasticity of a rubber ball and have it behave like a ball, we can give it characteristics and have it bounce around. So that's very unique, especially when you're dealing with structure. Finding optimal forms through gravity is a fantastic one. There's actually that's how a lot of the fabric. That's how what's one of the logics of how we make the fabric work is we have to apply a gravity factor to it, and then that really allows us to do some unique form finding and get us some very organic shapes. But they're not just shapes that, oh, this looks like a very cool organic shape. It's rooted in logic, and it's based on optimizing structural loads, and it's just this thin shell. So again, this is a great one. We won't dive too much into these, but there are fantastic resources out there that can dive into these. And they're constantly changing. There's constantly new ones, and these are constantly being updated. The AAD book that I recommended in the syllabus, if any of you guys purchased that, that goes into some of the key plugins, and even those are probably outdated. In fact, there's one plugin that they reference that doesn't even exist anymore because this is moving so quickly, and that book's probably only 2 years old. So it's constantly changing, and there's constantly new things that are coming out. I mean, there's one that's called Mosquito that actually is data harvesting through social media. So you can set up a script, and it can connect to Twitter, and it can start to scan hits on certain tweets. And so you can always link that to your geometry or something. And so you could always say, hey, build me a new stadium. Hey, we're going new Detroit stadium. And you can get all these retweets, and that can affect your geometry in Grasshopper or whatever formula you're working with. It's pretty amazing. I think recently I used that for Google Maps, and you were able to go use all the information from Google Maps, and it generates it as geometry into your Rhino, and it was great. So you can type. It was also weird as I typed in my house address in the Rhino model. It pointed exactly where my house was. So it's really pretty fascinating stuff that's going out there, and so you can really set up these scripts to mine data really well. Yeah, there's quite a bit, and I think there is there's also one. It's Lunchbox. Probably the only plugin that's not an animal. But Lunchbox is another great is another great plugin. It has just a lot of great basic, or just a lot of the fundamentals that most people would want to use in Grasshopper. And it just saves you a lot of time. So we're just going to download this. I don't even think I have this, but this is a little different installation. This one, there's actually an installer that we have to download. And each one will, it will tell you instructions when you download each one. Download it. There's Lunchbox installer. Probably need to close all this stuff out really quick.
Hey John, if our Rhino or Grasshopper already has Ladybug installed on it, where would we find it?
It would be, well, if you have Ladybug installed, the first thing you have, and we're trying to, I'm using the script that I'm using uses the latest download. So you would want to first read the installation, because you have to uninstall Ladybug first. But it would be, I'll show you really quick. Let's launch Rhino again. They tell you the file path. in Grasshopper and in Rhino.
With the plugins, do they automatically update, or do you have to go into Food for Rhino to update them?
Some of them, like Weaverbird, is one of the few that automatically updates. But most of them you do have to check periodically. That's why their newsletter is nice. Is because they'll tell you all the updates of things that are happening. And the installations aren't, and some of them aren't too drastic. Some of the updates, they might just tweak a bug or here and there, or they'll add a tool or script or two. But the installations are very quick. You download it and you just drag and drop it on your canvas and you're all set. They may update it maybe once every 2 or 3 months. But to get our locations, we want to do file, special folders. There's user objects and there's components. User objects, usually where most of the stuff is. And this tells you the link. I can never remember this link, so that's why I use the Grasshopper to help me out. So this is where all my Ladybug user objects are. And for Ladybug particularly, if you just highlight all these and delete them, it's still technically installed. So you have to follow their directions. It's really simple. I think it's really just, there's a small little plugin. There's a small little component on this. Update file. Oh, this is actually, you can update Ladybug like this. This is something this must be a new component. It can't be. So you could update Ladybug like this. And so when it's just in a component and it says set true, if you want this component, search through the current Grasshopper file and update Ladybug tool components. And that's just a simple, how do you get a true statement? Well, you use your Boolean toggle. You set to true and you plug it in. And let's grab a panel. And it says empty, so it's all up to date. If it isn't, it would probably say something. But yeah, the instructions will have something similar to what I just did as an installation, where you would have to, you grab a component, you put a true false into it, and it will uninstall it, and then you follow the directions again, then you drag and drop everything back in. There's Ladybug. So here's Lunchbox. So Lunchbox is a great one. This actually has some machine learning. This is actually some great components that I've been messing around with lately that are really, really cool, especially when you're dealing with point clouds. When you 3D scan something, it sends out millions and millions of points, and it scans the room. Well, the issue with those, when they're all points, when you put them into 3D model, it's like, well, these aren't really useful for me. They're just points. I need lines. I want something to snap to. How do I know that's the real corner? Well, what you can do is you can use some of these components, and you can use these machine learning components, and it can scan those points and start to read trends of those points, and it starts to be like, okay, these points are clustering right here, so this must be a corner, so I'm going to draw a line there. And then and it clusters here, so I'm going to draw a vertical line there, and it starts to learn patterns and where to draw lines, which is great, because then you're actually starting to get some 2D line work out of these. Some very accurate 2D line work out of a 3D point cloud. But this is probably one of the ones that, when I first started getting into this, was the panel tools, where you can start to panelize these surfaces. You can start to have them be made up of some pretty unique shapes of like diamonds. So if we made, slide this over. So we're gonna lock it. So we get our surface, then we can get the diamond surface, and it takes this surface and it creates it out of diamonds shapes. We'll hide these curves, and we can adjust how it's divided. So we can say, say 15. So we can get really smooth, or we can get it pre-tessellated. Then, like always, we can always manipulate this, and we can start to create some pretty cool forms out of this. Some pretty cool folded surfaces. I thought that was, you know, we can script it like that. We can make a script that does this. It takes a bit. It doesn't take too long. It does, but it's just cool that they have a nice component that helps, makes it quicker. So, and also they have some great workflows when you create Excels. You can create layers in Rhino. Just some great little things that that can help us out. You know, they even have attractors. You know, so you know what, that one class where I wrote that whole little script about attracting, you know, a point as an attractor. You know, they have a component just for that. How to read Excel, how to export to Excel. Just nice little randomly split lists. So some good stuff that I mean, stuff that I still use a lot today. So that's a great one that I highly recommend for that you guys should download. And we'll get, this is the assignment after this one, but the last one is Hummingbird. And that one, it converts Rhino shapes into Revit native shapes, which is a very different, you know, it's very different from creating a Rhino file and saving it and importing it into Revit. Well, when you do that, it's dumb. It's a dumb geometry. It doesn't have the information. Doesn't have the I for BIM. You know, it's dumb information. Well, Hummingbird allows us to export Rhino, convert Rhino geometry into an Excel spreadsheet, and then Revit will read the Excel spreadsheet and create a native Revit family out of it. And so now our crazy Rhino forms can be in Revit and their BIM, and it just makes a great workflow out of it. And that's probably some of the most advanced stuff we're going to get into. It's also some of the most important right now because interoperability is a huge factor in the business world right now. So, and I'll dig into that longer or next time why that's so important. So just a few plugins that I recommend just messing around with. But yeah, let's jump in to the assignment. we're going to launch. Oops. Open. I'm going to also open this one. All right, so I have my form from Galapagos. I ran Galapagos, I ran the optimization script. I now have a form. We're going to change our display settings really quick because it's a little tough to read. So we're going to perform that solar test, solar simulation. So the first thing we need to do is we need to input our massing model, and it's just from our assignment 2B, which is also referenced, which should be the model that was just updated from O2D. We're going to use this component called deconstruct BREP. And the reason why we have to deconstruct this massing model is this massing model reads as one solid face. And it reads a solid face here. In fact, if we explode this, it's going to read one big face there, one big face there. So that's an issue when we're running the solar analysis. It's something that we need to actually have this object broken up into a whole bunch of small different pieces for the solar analysis to read. If it doesn't do that, it's just going to read this as it's going to take all the calculations, all the solar exposure, and it's just going to average them out along this face. And so it's just going to make it one solid color. We don't want that. We want this especially if ours are twisting, we want this nice gradation pattern on it. So that's why we have to break it up. So this component deconstruct BREP, it breaks up the BREP into 3 different pieces: faces, edges, and vertices. So the difference between edges, so that is a face. Edges is the actual edge of these faces. And vertices are the points that make the corners that make up this BREP or this mass. We're not interested in the edges or the vertices. We're interested in the faces, this actual face. That's what we want to divide. So that's why we take our faces, we deconstruct it. So now all our faces are broken up. In fact, I'm going to undo the explode. We're just going to put this in here really quick. Sure, it's in there. Great, it's in there. And we're going to plug it right into there. And when we do that, we're going to see our points. We're going to see the vertices. We're also going to see the edges. I'm just going to slide this over. So if we get our curve, right, and we plug that into there, it should highlight all the curves that make up this shape. So there it is. If we grab our points component, it should show all the points that make up this object. And then if we put our BREP, it shows all the BREPs. They're made up of this face. So we want to connect that BREP into our list item. So why do we need our list item? This list item command calls out a particular item in a list. So it's going to call out, so if we have, I'm just going to show an example, a series. if I have a series and I want to call these out individually and just have a list of each individual one, but just have it as just, I just want that individual number. I don't want to graph this or branch this. I just want the number 6 out of this. I can say list item, plug this in, and notice these are our indexes. These are the index that represents these values. So what list item is it looking for? Is it's looking for a list, an index, item index, and there's a wrap list bound, which we won't get into. We're really just looking for that I, the index. So we're going to, it's we want that 6. We're just going to grab a panel tool, type in 2. And when we put 2 in, should give us the number 6. We can also copy this down. There's also another way we can do that. We're going to disconnect this. If we hover close into the I, we see these pluses. We're going to add this. And then when we grab our panel tool, these I's are index. That represents the index. So it's index, index plus 1, index plus 2, 3, 4. So when we grab a panel tool, I represents 0. It's going to grab index 0, which is 0, just like that list. We're going to do that. We're going to plug that into 1. That's our 3. We're going to pull it from 2. So remember, all these 0, 1, 2, 3, 4, 5, 6 are all referencing that series list. So that's how we are getting all these indexes. So that's why we have this part here. We're getting our list of BREPs. And we notice there it's 6 pieces, and it's 6 pieces because it's taking the 4 sides, the top, and the bottom. So notice that we only have 5 divide faces. That's because we're not going to run a solar analysis on the bottom because we know the answer of that. We want to run the solar analysis of the 4 sides and the top of this. So the key thing is just to understand when you connect this, very similar to how we did this, where we were able to see which face it is, or if it's a face, which face, edge, or vertices. We can do that with this as well. We can start to understand that's the top, that's the sides, that's side 1, side 2, side 3, or side 4, or it could be side 1, side 2, side 3, side 4, and then the top. It could come out in a different order, but we really just, and it doesn't matter which order, but we're really just looking for, just to get those 5 faces. Once we have those 5 faces isolated, now we need to start dividing them up. So very similar to what we did from the last assignment, except this one we don't have to worry about those errors of those domain and deconstructing the domain to divide up this. It doesn't apply for this one, but we're going to then input our surface and we're going to divide it up. And we're going to divide it based off the max number of levels that we have from assignment O2A. Just a common number that we've been using through all these assignments. And so it's going to break up the masses into this whole grid. And then once all these little, so it's all these little surfaces now are going to be made up of this. And now we have to recombine it all. And we have to mesh it. So this one component, it's called unified normals of a mesh. So brief, back in module 2, when we were talking about 3D modeling, and sometimes like with SketchUp, the mesh is flipped the other way. It's supposed to be a white, but then it's flipped and it's actually a gray base. Well, sometimes that can happen in Rhino for meshes. And like I said, the computer is stupid. Sometimes, even though all these meshes are created the same way, sometimes the computer gets confused and it flips a mesh. And when the mesh flips, the simulation won't read that mesh correctly. It would either be just a solid color and won't have that nice gradient effect to it. Or you'll just see it's blatantly a different color. You'll have like this nice gradation from red to yellow, and then you'll just get this blue. And you're like, what the heck? Why do I have this random blue square on my building? Well, it's because the mesh was flipped. When it was created, it flipped it around. So this component fixes that. It's called Unify Mesh. And it takes all the mesh normals and makes sure they're all facing the right direction. And that goes into our massing model. And then we have to input our city again. And we can use that from, it shouldn't say O4A, it should be called O2D. And we're going to use that same component, and we're going to reference, and we're going to plug it right into this. And that does the same thing. It's going to take that BREP, and it's going to mesh it. In this case, we don't worry about the meshes being uniform, but we're really just using it as context, because some of these buildings during the simulation are going to cast shadows on our building, and we want to pick up that. We want the simulation to understand that how it's going to be working, especially if I'm doing a solar analysis on this building, because I want to know how this monster is going to affect me. So that's why we want to grab that context of the city. The next is our initial ground plane. And this is very simple. It's just grabbing a BREP and just drawing a surface. And that surface can be, preferably just try to make it within the bounds of this. Because we want to pick up that ground plane. Sure. Yeah, we just want to pick up that ground plane so we get those readings. So we start to see how our building is affecting the ground plane. Similar to what this is doing, that's going to pick that up. And we start to see how some of the buildings are even casting shadows on the ground. So we want to just grab that, and we'll just set as a BREP. So our location. This website is, we are actually, I'll show you. I don't think we need to dive too deep into how we do it. It's actually referencing Detroit. But if we need to change the location, we can copy and paste this URL. And this is the most user-friendly, boring website I've been to in a while. But we can select our weather by state. If we go to Michigan, and we can start to see how it's broken up. Now, the tough thing is it's broken up by locations of where they're reading the data. A lot of times they're at airports, but you click the airport that's closest to you, or closest to whatever project location you want it to be, and I believe we just need the all. I'll totally quick. Copy, paste. We copy paste that URL, and I believe we do a \all. And we put that into the weather file URL. And then it will read. Now you do have to have internet access for this to work. You don't necessarily have to. You can actually download a sample of the EPW file, which is the file that contains all the weather data. It's just, you could always just instead of downloading something, you just reference it from online, but you can just download an EPW, and it's just this simple file. And just like anything else, you can do EPW. Ladybug has all these import tools of how it reads the weather data. So we can do Ladybug. It's the very first thing, very first tab, and it will say download EPW weather file, import it. You can, and let's just say that. So this one, it pretty much takes that file and breaks it up based off like all the information. So you can break it out into what's the latitude of that location that you're taking that EPW. This is some of the stuff that we won't be getting into. This is some honeybee stuff where it's talking about dry bulb temperature, dew point temperature. But we can grab like I believe we can grab a wind speed from Ladybug, but you can also just do a file path. Right click it, and you can select one existing file, and it should bring in your command prompt, and you can actually go to downloads, grab the EPW, and then you're able to, and then you have the EPW file all set up. I believe you can just plug that right in into the working directory. Actually, I don't think you can. I believe you put it into this one. You put it as, when it's looking for EPW import location, you plug it right into there. But since that's a whole other step, I thought it's just easier to just reference the link and just use the links for it. So once we have that location of our of our study set up, we need to set the time and date. So we can always use static numbers. We can always say, okay, on this date, on this month, on this day, and on this hour, do a solar analysis. Or we can do a series, plug a series component in, and we can do this for any of these components if we wanted to. We can do it on. We can say, okay, between on June 21st, between 9 a.m. June 21st, starting at 9 a.m. We want a solar analysis for 12 hours. Give us the result. So we can do that same for months and days. We can plug in the series and it can run. We do it for all 360 hours, 360 days, 364 days so for that. But it's a great tool that we can use. And some of these center of site. Oh, and also we also need a location of where we're going to perform the study, because right now it's looking for like, okay, where in the Rhino coordinates am I going to perform this study? And so we just need the center of the site to do that. So, and the north, you do want to set the north, we're just going to says the default. It's already set for us because up is, the default is, okay, north is in the Y direction. A lot of these, you do not have to touch. We're not touching a lot of this stuff. We're only touching hours, days, month, and center of site. And of course, our location's already plugged in for us. So it's only those five components that we're plugging in, and for that solar analysis. But that's only part of the solar analysis, because we also need to create a legend. Okay, so it's like you perform this solar analysis, but what does it mean? So this legend, so this just creates this legend for us, and this is such a simple one that I just left this as already plugged in, but it is a nice nice little item to have. The last one, or the last two, are the solar analysis for the ground, which is which we're going to be inputting our input ground plane. Oh, I'm sorry. We're also looking, and this goes back to that, we're also looking for the geometry. So it's important when I said solar analysis on building, geometry is the next thing we need to input. We need the object to input. So it's oh, I'm sorry. I kind of got ahead of myself. I'm sorry. This sets up our time of when we're going to perform the analysis. These are the objects that we're going to perform the analysis on. So our solar analysis on our ground, which we're looking at the geometry, the contacts, grid size. Now, grid size is when it reads this geometry, it's going to break them up into it's going to break up that, breaking up isn't the right word. It's going to read this plane into pieces. And so we set the ground plane at, in this case, like 100-foot by 100-foot grid. That's a huge grid. And I'm assuming we're all going to stay in feet for this. And please stay in feet. Don't switch this to inches, because this will blow up the machine, because it'll read it as 100 inches by 100 inches. And that's an entire city, or a quarter or eighth of a city. So it will chug for a long time. But this is just a very, very low resolution study, and I want you guys to do more of something that's a more accurate study. for that. And so, so that's what I specified on this, on perform an accurate analysis by measuring the amount of solar exposure every 1 foot on the proposed design scheme and every 10 feet on the ground plane. So really important when you're doing when you're just testing this script, just keep it at 100. Just make sure you're getting make sure it works and it sets up. Because if it is set up and you actually had this at 10, it does take a few minutes to process all this information. There's a lot of data that it's going through. So just be careful with that, because there's actually there was a coworker pulled me aside saying that they're trying to do a solar analysis, and every time they opened up this script and clicked the run, it would crash their computer. And we're baffled by this, and I would open up my model and it would work on some and it would crash on others. And I'm like, why is this not working? Well, it was our units are set. Some of our models were set to feet, some of them were set to inches, and this was set at like a 1. And we had a really large model. So it was, so when we would read in inches, it would say, okay, I'm going to do a solar analysis on every square inch of this building. And this was like I said, this was a big model. And so we were like, that's why it kept on crashing. So just like I said, just be careful from that. There's this distance from base. This is one of those very similar to how I was mentioning last night about points overlapping and how the Grasshopper has an error with that. This component actually has a whole factor on that. We want this simulation to be read about 1 foot off from the ground. So distance from base, it's gonna do just a quick offset. You won't even notice it. It's gonna be in the background, but on how it calculates it and stuff. But it's just one of those Grasshopper issues that comes up. If you are getting a lot of random, if you unified the mesh and you're still getting a lot of weird readings where it's just like you get this nice gradient and pow, you get all these blue spots, and then it goes back to normal. And you're looking at the geometry and you're like, this just doesn't make sense why I have all these blue spots. It's probably because this variable, it either needs to get larger or smaller. Now in this case, when I was first writing this script, I usually have this number very small. Like I used in the previous assignments, it was 0.01. That usually is my go-to number. It's small, it works. But in this case, that was too small, and I was getting some very weird results. So I had to increase this number to get the results that were correct. So just keep in mind, if you are getting some weird ones in your weird results and you're not sure, and your meshes are unified, it might be because of this. Orientation, don't have to worry about that one. Sun vector, I plugged a lot of these already in for you, just because some of this is just knowing how the plugin works, and just the logic behind it. That's a whole other thing I didn't want to bog down this class with. I just want people to get familiar with running simulations and seeing the output of this. So parallel, again, we'll keep that as a true. We don't need to worry about that. And I'll go into the bake later on. And so that was all for our ground. Our building is the same thing. We're going to run it through and we essentially plug things very similar. Of course, we have our grid on our building, and we'll run through and it's pretty much identical to this one up above. So to run this simulation, when you connect all these, the simulation won't run. We have this special toggle here, that true false, that is connected to our run it on both of these. So when we double click on this false and switch it to true, that's when the simulation will click on. And that's where as soon as you do it, you're going to get that spinning wheel. And it's going to take us, and it's going to sit there and it's going to think. And when it's done, you're able to preview these, and you should be able to start to see your mesh. And you start to see some of the colors. The interesting thing is, you can't bake it, baking this, so if you just right click and say bake, you're not going to get the colors from the bake. This is part of what makes Ladybug special, is it's able to bake colors into the mesh. So that's why just right clicking it and bake, you're just going to get a typical black and white mesh or gray mesh, and it has no characteristics. That's why we have these special buttons. So when you click this button, and it's really just a click, it will automatically bake it, and it will have its color, and it's exactly what you see in the preview for this. And so you click those two, that bakes that into your Rhino, and then you're able to capture your perspective and do a view capture to save. And if it's working, save your script off as a high res, and then you can start to 3D print this object and take a photograph of it. But yeah, that's about it. It's we'll try to keep this one pretty simple. Like I said, these are there's also a great resource if you're having trouble. Ladybug, I think they acknowledge, if you go to the Ladybug website, they have some great resources. Oops. Ladybug tools. They have some great resources of how to run it and just what they're about. These just shows you how interconnected all these are and just how involved they are with all these environmental programs and systems and studies. So they are pretty amazing. But there's education, resources, talks about, this is actually Dynamo. So you can, if you are a Revit savvy person, there's Dynamo, which is a visual programming for that. You have Ladybug for Dynamo. You can watch all these, you can read the primer. They have lots of example files, and they have just a massive library they just have a massive library of just videos to watch. Services. They have this great, and I can never find it on their website, but it's they have this that they update. It's called the Hydra server, and it's just a GitHub library of Ladybug and Honeybee files, and these are fantastic files. I use these. Other employees use these. This is a great way to just and they're all set up very easy for everyone to use. But yeah, it's really just you pick on something. Like if we wanted to start to look at bounce from surface, the daylight bounce of a surface from a building. Here's the script. We can start to zoom in on it. They should have a little example file to show it to you. And should be, yeah, download right here. And it should give you a Grasshopper file and a Rhino file. It might just give you a Grasshopper file. Some of them just give you a Grasshopper file. Oh yeah. Drag it like that, and we can just draw. Have that open, and there it is. And it's all set up. And it even tells you, you can change your hour, some location, and I'm sure we can just drop. I'm sure they have a geometry art baked in here that we can just that you can swap out. Yeah, there's our ground plane. Yeah, it looks like this is the geometry. No, it's not. But we're able to, but the file is all set up for you to start messing around and start using these. And so, like I said, it's a great little tool to just get a nice baseline if you want to try some new scripts out. Also, you may notice you get this, you have this little component up here, and you'll see it for here. There's nothing that connects to this. This is actually a is a component that I believe you just have to have on your canvas for Ladybug to work. So don't worry about connecting this to anything. In fact, you just probably put it way up in this corner. You can probably forget about it. But it's just nice. It also tells you the version and all that stuff. But yeah, so that's about it for today. Like I said, it's going to be a little shorter class today, but does anyone have any questions?
Are you okay with us just doing what you did and just getting rid of the previous script that we had and just, mapping the baked the baked building that we picked?
Yeah.
Okay,
yeah.
So we don't have to keep the other stuff. Okay.
Yeah, for we're kind of wrapping things up where we don't need to reference all that other stuff now. It's not really going anywhere. So yeah, you can just bake that stuff and just input those numbers.
And do you care if we pick a weather location closer to us instead of Michigan, or we could pick anything?
No, I prefer you guys picking something else. I prefer, please don't use Detroit. And yeah, and change your times up and do all that stuff. Yeah. Please pick somewhere else. And if it's not working using that /all, try the EPW. Get it actually download it on. That works as well. So, but yeah. Any more questions?
I have a question on 2D, but I can wait till after.
No. If we're all good with this, yeah, we can jump to 2D.
Just real quick before you do, when I'm working through the 2E, I'm like reconstructing the massing model and the join mesh, unified mesh. It gets to the massing model at the end and it's red, and I don't know how to diagnose a red node.
I'm getting the same thing.
Let's see. Oh, you know why?
No.
Sorry. Sorry, that's why you're asking.
That's why we're asking.
Yeah. Sorry. It's we're putting the component into a B-rep. Should be a mesh. That's why. So just and notice the icon, it says B-rep massing model. Let's delete that. We want a mesh massing model. So yeah, we just type in mesh. Here it is, and we can plug that right in.
Makes the next one. So the massing model over at the other end should be a mesh as well.
Yes, yes.
Okay.
So that context of city is mesh, ground plane, that works. Massing model. Yes, that should be a mesh. Yes, that's why it's glowing red. And if it does that, let me do that really quick. Yeah, it should tell you the dead giveaway. It's a B-rep. Oh, it actually worked. That's weird, that's why. It will, if it glows red, its warning will most likely say data conversion. That's just has a tough time convert stuff. Converting it from a B-rep to a mesh, or mesh to a B-rep, but we want it to be a mesh. Great. Anything else before we jump to 2D? All right, well, cool. Let's, so 2D. Sorry, I didn't see you on the screen when you spoke. So, who had a question on 2D?
Oh, I did, John.
Okay. Okay, cool. What, do you want to share your screen?
Sure, I'll go ahead. Okay, can you see that?
Yeah.
All right, I'll try to get Grasshopper out of the way. So the question I have is, I've got the perspective here with the rays, and then can you remind me again how to turn off the rays if I want to just do the perspective of the building itself?
Yeah, so all the rays are generated from the SDL line. So if you go into your Grasshopper script and you zoom in onto, okay, first, so let's turn off that line component when it says call sort views. So we can, yeah, there we go, unclick preview. And then we want to slide over towards the end. Yeah, so then we see that there, right after the SDL line, right click that and unpreview that. And if you want to get rid of that circle, it's just unpreview that circle from the beginning. I don't think you'll see it in your views, but you could always unpreview that.
Oh, okay.
And yeah, and and then you should that should be it. And then I would then go back to the script from 0 to B, and you can bake that in.
And do you know how to get rid of the floor plan?
Yep, it's the same way. We just go over to our rendered floor plan section of the preview of O2D or OTB. In fact, we can just drag a window up to the other. There you go. Rendered floor plans. we can just drag a window over all those components. Center click, if you have a center wheel, and it's center click on a component.
I'm just using a trackpad, so I'm not sure.
Oh, okay. Then don't worry about this. Then just deselect it. Hover over the preview from the gradations. So just, yep, right click on that and uncheck preview. And same with your elevators. Oh, your black is the previews.
Oh, okay.
And actually, it might say, we might have to take off the render. I lied. We go back over to the preview. Do click render. There we go. That's better. And then to get rid of those lines, you can just highlight the merge and orient and unpreview those.
Got it.
And yep. And that's the tricky thing is when you mess around with some of these display settings, you have to click on the actual like black part that has the text on it.
Sure.
Because that's where it actually gets to the component options. If you click to the left or right, then you're getting into the inputs and outputs options.
Okay.
But it should be, it looks like you just have to unrender your preview for your elevator shafts. And
Oh, okay. Sure.
yeah,
And then-
with a mouse, if you had like a center button, you could just highlight everything and then you can just unpreview everything off.
Sure. Okay. And then the building view itself, it's is there let's see, I think I have it in a shaded view, or I have it in Arctic right now, but I'm not sure why it's showing up as this red wire mesh.
So it's like that because it's still in Grasshopper.
Oh, okay.
So you just have to go back to your O2B massing component
Okay.
and just yeah, actually you got right there in the massing, yeah, massing model. Yep, right click on that and bake it. And it's going to ask you what layer. You can put on any one you want to. Or, you should, yeah. Sometimes it just, yeah, bake it because then we can, and it should be there. And then also unpreview, turn off the preview for the massing model. It'll get rid of that red. There it is. And it looks like you have your series component still turned on.
Oh, okay.
And that will get rid of the lines as well.
Got it. Okay, great. Thanks.
Yeah. No problem. Great. Anyone else?
I got a question on mine, but it's in the middle of running, so I don't know. I don't really want to stop it. I was running the same problem as Matt and Elise and not able to get those rays out. And I did what they did, and it has like a boundary around it where the rays should punch through the good views. Does that make sense? But it's not punching through. I don't know. Anyways, I might just. I don't know what to do. It's so late in the game.
No. Do you want to share your screen?
Yeah, but it's
If it's
it's running, so I don't want to screw it up.
how long did it take most of it for everyone for the simulation to run just to get to 12 generations? Was it a few hours or
Like 20 hours.
20 hours?
I ran it overnight, man.
Mine ran for an hour, 56 minutes, and it completed.
To get it to just I mean, like right now, like like you're doing twice the amount of simulations, which is fine. It's not gonna hurt anything. But I was looking for just a 12. So so it still took some of you like an hour for it.
Mine only took about like 20, 30 minutes.
Okay.
But I turned all the previews off. I turned everything off. Like you
Yes.
said.
That's a huge factor. If you start to mess around with some of those and you turn off some of the components, that will help tremendously.
Yeah, I have no idea why mine took so long, but it turned out, and so I'll go with that.
Okay. Well, as long as as long as it works, because that, well, it's good to know next time because, sometimes everything behaves a little differently on everyone's computer.
I have a quick question with what I think this is Megan's, right? Megan has on screen. So with the example that we did for last class, it was kind of intuitive because you wanted to get to 300 square feet, I think it was. And you're like, okay, whatever's the closest to 300 because it's like 299.99, whatever. And so that's the one we're going to select. With this one, for me anyway, it was not as intuitive what the numbers meant for some reason. And I was just wondering, I just went through all of them and picked the one that looked like it had the most rays going through that particular area. And also with the higher number. But what do these numbers really mean, and what is the difference between like the green long band and the small short band? Like I didn't really understand that. I just went through all the iterations and picked the one that looked like it covered most of the territory.
So I think some of the most interesting things about this Galapagos is when there isn't a correct answer. So that's why we set up the rays. In that intuitive one, we knew the answer and it was just more of an example. With this, we don't know what the maximum is. We want the computer to figure out the maximum for us. And so there's a lot of unknowns that we just don't know. We would have to, for us to know this, we would have to actually start to explore some design options and do these by hand. But we want the computer to do it. We want them to help alleviate some of our workload. So that's why it's such an unknown thing. It's like that's why it's just saying, okay, find the maximum, give us the best, or give us the most number. I'm not sure what the highest number is, but just give me the highest number, so I can actually now start to understand this. It's almost like working backwards a little bit. Give me all the solutions, and then I can start to evaluate which one's the best. But that's why. To be perfectly honest about the genome part, I'm not quite sure on graphically why it's doing that. It might be because it's hitting, a lot of the results are hitting that. I'm not exactly sure.
I mean, I wasn't obviously either, but one thought crossed my mind is that, there were some that didn't hit that, key spot as much as others, but it had a lot of values elsewhere. And I was like, well, that's not as important, I thought, because it didn't hit visually, it didn't hit the key view as often as some of the others. I don't know. I just picked one.
No, that's fine. That's fine. The goal is for the objective that I was hoping everyone to understand to get was just we're able to tell the computer to do something for us and to help assist us into designing. And now it's up to us to evaluate if that's the design we want to go with. And at the end of the day, we're the ones who get to decide this. The computer doesn't decide. The computer, we can set up the logic for the computer to say this is the best solution. Logically through all of the scripting, these are the five best solutions I could come up with. But that might not be the solutions that we're looking for. It's up to us to evaluate and be the designer and pick those. and actually tweak them if we need to. And almost every time I've ran this and gotten a design out of it, I've always tweaked it, and it was like, you know, it's within the ballpark. It informed me where the general location should be, but I'm just going to tweak it because I can, because you know, this makes more sense if I just shift this over a little bit. Is it the most optimal solution that this thing is saying? No, but it makes more sense within the context of the scenario that I didn't script. So that's so yeah, it is. I think that's the most interesting thing about this tool is when you give it a scenario and there isn't really a true answer to it. It's just have this thing crank out design options for you, and then you can evaluate it. It's a lot easier to edit than to start something from scratch. So one thing, Megan, that I'm saying is, yeah, it's not hitting, and we can probably stop the simulation. You're like almost 3 times. Like I said, we only need the 12, and it's hitting. Oh, actually, yeah. Actually, can we? So actually, okay. You had it running on the fastest setting, so it wasn't showing.
Yeah.
But even though it was showing, that's interesting. But it looks like though the lines are longer. Are they? Or no? Are they all? No, they're all the same.
Yeah.
So that must be because. Can we see that script really quick?
Yeah. So
we would.
Do I just say like okay, and then I go over there? I haven't even like gotten this
Yeah.
far yet.
I mean, we're gonna have to rerun it anyways. If it's,
Okay.
I mean, it was cranking through it pretty quickly, so it shouldn't.
Yeah, I
take,
like picked up there in the end, which is nice. I don't know
Yeah.
why.
So
Okay.
can we zoom in into the view weight?
The view weight, yes.
Okay, so your domain, your 0 to 7 domain, that should be plugged into your T value for remap, not your S.
Okay.
So if we disconnect that.
I don't know how many times I've looked at this, and then
Oh,
I just realized.
It's the other day, same thing happened to me. I was like,
Oh, no.
so let's
And
also.
then, go ahead.
Actually, might be easier if I just request control really quick.
Okay.
Okay, because I think when we have our calls, 194. Let's see, who's this? Sort works. So the next thing. So that's the location that we want it to go in. And if we, oh wait. Yeah, sort that. You might have something that was on. Okay. So it wasn't hitting that. Oh, also this U,
Mm-hmm.
we don't need to connect that. There we go.
Okay.
So then that's our starting point. So A, B, U. And let's see what our values are being cranked out to be.
Wait, go back. There's something messed up in that last script. Right there.
Yeah.
The bottom index should be going up to the B.
Yes, you're right.
Okay. I was like, okay. Like it
So,
goes
yeah.
to something.
No, you're fine. That was a good catch. So yeah, right now as it's set up, it's not using the weight value. So if we plug that in, there we go.
Oh, yay.
Yeah. So that should work. Now that it's hitting that weight value and the lines are growing,
Cool.
hopefully that works now.
Thanks, guys.
Yeah, no problem. Does anyone else have any questions? I know some of you sent me some Grasshopper scripts to take a look at. I haven't. I was actually going to save them for us for this period, but does anyone else have stuff to show?
No, I had questions, but after our meeting yesterday, I think I figured a lot of things out. Was able to get it done and
Okay.
submit it.
Good.
So,
Good. All right. Well, great. Then if we're all set here, tonight at 11:59, just please don't forget to submit. The faster people submit these, the faster I can grade them and give them back to you guys. So if something happens with that mask, you get the correct mask. Even though I won't mark you down if you don't have the correct mask. Just make sure, just to get everyone's feedback and then the grade books as well. But okay, if not, all right, we'll have in class a little early tonight.
okay. Thank you.
Great.
Thanks,
Thanks
John.
everyone.
All right,
Thank
thanks,
you.
John.
Have a
Have
good
a
one.
good night.
Good
Yeah.
night.
Happy snow day in Michigan.
Oh,
Our
nice.
kids just-
Soon.
Our
Soon.
kids just got called off.
Oh, it did? Oh gosh. Yeah, I hear it's quite a bit of snow coming. I had all these field studies I had to run out today to do because I was like, I don't want to get caught in the snow tomorrow.
Yep, it's coming. All right, have a good one.
Have a good one. Bye. Bye everyone.